Hi there, this is Jacob Nash, and here's the next review video on derivatives. Um, something kind of shifted with the video, so I'll try to make sure this is in the frame the best it can be, but it's kind of mirrored or something, so it's hard for me to do that. But let's first talk about the limit definition of a derivative. So remember, we know our derivative rules now, but remember, you still will have to know that this is also another way to write it, which just basically means um, sorry about that. So it basically just means that you plug in an h anywhere you see an x for this part right here. You just subtract a function by h. Then you would just simplify this. You would factor this out, and then or just actually just evaluate just whatever it is, and then things will cancel out, and then you'll get your answer. All right. Where is a function not differentiable? We have a vertical tangent line like that. That happens to be the case for this function, cube root of x. We have corners or cusps, so like absolute value. And then if anywhere like this, also it's not differentiable there. If it's differentiable, it's continuous. If it's continuous, it's not necessarily differentiable. We already talked about the derivative rules, so I'm not going to go over that right now. Let's talk about logarithmic differentiation. Log diff. This is a technique we can use when you have a function to a function, like this. What you do is you first do ln of both sides. So we ln of y, and then we can move this square root of x to side. That's the point of doing it. Now you would get 1 over y prime over there, and then this is just product rule. And you go from there. Sorry if I'm a little bit sick right now, so it's kind of making me not be able to speak properly or whatever. Seems like every time I make a video this happens, but whatever. Uh, Linear approximations. This is something we can use to do things like this. Oh, what is square root of 80? Something like that. There's a formula that you have to remember. L of x equals f of a plus f prime of a times x minus a. This is really simply just a point slope formula, which is just kind of rearranged so it's like this. Because point slope formula, this would just be on the other side. I'm sorry, that wasn't in the frame. So every time you do a problem like this, you have to first find f prime of x. So that means you just take the derivative of the function. Then you do f of a. So you plug in the a value that you have. I've said this before. If you don't understand what I'm talking about, please watch the specific video because I can't go through that right now. Then what is f of a? Okay. And pause again, sorry. Okay, sorry about that. Of course, my computer decides it wants to die right now, so I had to plug it in. Um, my videos suck. Sorry about that. Implicit differentiation. what we had been doing was explicit. If it's an explicit function, there's only one solution, one possibility. Implicit differentiation, that's where you might have like a y squared. And what you do for that is just remember how we get our ddx. It's really ddy times dy over dx. Dy's cancel out. That's kind of how that goes, and that's why this ends up being y prime. So for that, just remember you had something like this. They wanted you to do the derivative of this. It's going to end up being this. You always have to put a y prime by it because if they said ddx, then that ends up being that. If it was ddy instead, we would have an x prime there. So then we have this byproduct rule. Okay. Next thing is related rates. I'm not going to talk about that in this video really because I have a video specifically on that already. But just remember that a good acronym to know is KNES. I always have used that. Write what you know, like what they told you. Write what you need to find. What are they asking you to find? Write what equations you'll need. Because remember, for related rates, you're basically just kind of connecting two equations. You're putting them together to find something that you solve. You also always want to draw what they are talking about. That really helps. You get that horrible stoplight or spotlight problem, you'll want to know how to do it. Next thing, the last thing in this video that we'll talk about is Newton's method. Not Nash's method, Newton's method. And this is how we can basically approximate zeros, meaning we have something like this. What we do is, okay, let's say we choose this to be our first x. We go up to here. What's the slope right there? We go down to here. Go back up there. It's the slope. And you just continue until you get to whatever you want. It's not the only thing it could be used for, but to find the next x to use, if you can't do it graphically, is what x you just did minus f of that x that you just did divided by the derivative of that x that you just did. Newton's method can fail. You'll need to know that that's if the derivative equals 0. So if you try to do Newton's on the flat thing, that's not going to work. If it oscillates, so if it's like, oh, go here, go here, go here, like that, that's going to be bad. Or if it can sometimes go to the wrong 0 that you weren't trying to find. That's where Newton's method can fail.